Assalamualaikum and a very good evening to everyone. Today we are going to do experiments based on the concept
Sound and light. So, my name is Aiman. As you can see, I am not a boy. I'm a girl, even though my name is Aiman.
and I am Deena and we are both from Ibn Sina. So let's move on to our first experiment. I'm sorry for my finger. Our first experiment is very simple.
And we and you can do this at home with your brothers and sisters, mothers and grandpas and aunts
Everyone.
and uncles, everyone.
Everyone in your family can do it. It's very simple, and today we're going to teach you how to make a musical instrument from one straw. Just a straw. So, how do we do this, Simon?
So, firstly, we're going to cut the straw into a shape that we need. Okay.
So, we have to cut them so that we can get pointed ends. So, as you can see, I've prepared here straws with different lengths. So, I'm going to show you what is the difference between the straws that have different lengths. So, let me take the shortest and the longest. Let me see. Do you want to know what it sounds like?
Yes.
You do?
You know what? So that is what the longest sounds like. Now the
So?
shortest. You can see that the longest has the higher note and the shortest has the lower note.
Backwards. It's backwards. I'm sorry. Actually, the shorter one has the higher note, and the long one has the lower note. So I'm going to have one volunteer
Come
to
on.
show.
To play the
Come on.
the strong.
Everybody clap. So for our brave volunteer today, she's going to blow it while I'm going to cut it, and you're going to see the difference. Yes. No. Okay, so you have to blow it and find a place in your mouth where it can make the sound.
Or else you
Try to blow from this direction.
Yes. You have to put all in your mouth, about here maybe.
Okay. Put it down.
You have to bite it a little.
Oh.
Can you do it?
No, you can't do it.
Oh.
Can I try it one more time? How to bite it?
Just bite it a little. Like here. If I have this one, see? Here.
And
And you have to blow.
I can't.
Okay, so I'll do it.
Use this, the longest. I will be cutting the straw.
Thank you, Nuresh.
Thank you.
Okay.
We apologize.
Sorry.
You guys have to see the difference.
Yeah.
One,
No, I can't do it anymore. Actually, blowing it up makes you dizzy, and now I'm all dizzy. So, the point of our experiment is, you can see, sound is created by vibrations. And when you put it in your mouth,
in the correct place.
these pointed ends will vibrate and create a sound. And you can see that I've drawn here, this is the long piece of straw. So when you blow it, there will be a sound, and it will create sound waves, will travel through the straw. When you cut the straw into smaller pieces, the length of the wave gets cut short too. So the conclusion is, the smaller the piece of straw, the shorter the sound waves are, and the higher the pitch of sound.
Yes. So move on to our next experiment. So, how many of you here have always been singing in front of the mirror with a cone without a microphone? Really? We all do actually. So, today we're gonna make a microphone out of some things that you can find at home. For example, a matchbox. We just
something that all students have, I think, unless you use pens all the time, lead. The thick one and the thinner one.
Yes. So what we had to do is that we put 2 holes in on this matchbox to put the lid on. As you can see, we're using a big speaker.
And we also have earphones. First we're going to do it with earphones. So anyone who wants to try to hear it with earphones can come up front after this. Let's set up first. So the first is you have to put the leads here. Let me put it up for you. Leads through the hole. It's too short.
Okay. So next time you can do it at home, I think. But you can also use a battery
Instead of this.
this power supply. You can
So-
use a battery for smaller
You
books.
clip and put these inside. Oh my god, it broke.
So we put it into the holes that we need and put a thicker lead onto the thinner lead.
Yeah. No.
No, it's not.
Wait a minute.
Okay.
We'll have to take a longer lead. So
I'm so sorry.
this takes a long time because the thinner lead is very fragile, so you have to be careful so it doesn't break.
Yes.
So we put it inside here. Can you do it?
Sure.
It's hard with this thing. Alright. So on another note, maybe we'll pass on the earphones because earlier when we did this with earphones we used the battery. So we're afraid that this would affect the earphones because
And affect
it's
your ears.
yeah, it'll affect your ears. So we'll be using the speaker. So you can see, well you can't see actually because you're sitting down.
So you can come here if you want.
No, it's not dangerous.
Seriously, it's not dangerous.
So
First, no, I have okay, first when
so we've connected everything.
yes, and then turn the power on. You see there's no sound, right? So now we're going to put this thick, small lead on.
You can see that it creates a sound. And then, let's see when I tap it.
It acts like a microphone.
And be careful because of the electricity, it gets hot. So you can't touch it, the lead, because the lead is a conductor.
So does anyone want to try to scream at the microphone?
And see if your voice gets projected.
Hi! Just scream, just scream.
See if it affects.
It affects.
Okay.
Yeah.
Okay.
It works. It's alive.
And so we'll explain it to you.
How it works.
So remember about that comb that you use as a microphone. This matchbox also acts like a smaller and much simpler microphone. So can you read it, Sal?
Sure. A microphone converts acoustical energy known as sound waves into an electrical energy known as audio sound. Inside the head of the microphone, you will find a diagram which is a thin piece of material responsible for the conversion.
You see, when the diaphragm, which in case of the matchbox is the leads, is hit by sound waves, it vibrates. And it is these vibrations which are converted into audio signal and what you can hear through the speaker. So that's all for our sound experiment, which is part 1 of our experiment.
And now as we go over here,
You can see that we prepared a lot, but
you can see that we prepared the light part of the experiment be in front of a black curtain because that we need dimmer light for this experiment.
for the first show of refraction, I want to ask you, does anyone have coins?
Yes.
Can we have some coins? Do you have some? Okay, thank you.
You do. Thank you.
So, we have one here. Any more?
Any more? No, you don't have any more.
No,
Okay,
okay,
it's
it's
okay. You can come closer to watch how it happens. So, as you can see, my partner will put the coin on the pad.
And for you to be more
Success.
convinced, I'll prepare some coins myself.
Yes, you do. Okay. Okay.
So, we'll cover the coins. Oh, it's too much.
Now, I will put this beaker onto the coins and put water, and you guys see what will happen.
You can see through the water.
Look.
Where are the coins?
The coins have disappeared.
Can you see the coins?
Where are the coins?
Can you see the coins? Do you want to come closer?
Come closer, come closer.
If you
You
want to
see.
come closer,
You
you can
see.
see from above. The coins are there, aren't they?
The coins are there, but at the bottom, the coins had disappeared. How does this happen, Deena?
I don't know. Shouldn't we try another experiment to explain this?
Yes, we should.
We should.
We should. So, as I remove that the coins are still there, why does this happen? To prove you more how this happens, we're going to yes, our third experiment. So, to continue our experiment,
But before that, for the coin experiment, I told you that it was refraction. It was a mistake. It was actually total internal reflection.
Yes.
So we're going to show it now.
yes, I will be handling a laser today.
A laser. And this is a bottle filled with water, and it has a hole actually. And if you listen, well,
You
never
can
mind.
come closer if you want.
So we're going to let the water flow.
This experiment is called bending light. We're going to break the laws of light.
So let's see.
Where's the...
Over here, over here, over here.
Okay, I found it.
You can see that the laser goes along with the water and drops into the bowl. Can you see it? Can you see it? So,
Yeah.
does anyone want to try?
Yes, does
pointing
anyone
the
want to
laser
try?
to the hole?
Do you want to try? Come on.
Come on, come
Come
on.
on.
Anyone?
Anyone, you can try. Okay. To prove that we are not kidding about
To prove that we are not doing any tricks, you can do it by yourself. So, let's see.
Okay.
Okay, let's see. The holes over here, bit over here.
Light follows the flow of the water into the bowl.
Okay, thank you. You're such a brave volunteer. So, you can see we're going to explain to you why does this happen. So, the bending of light.
Okay. This experiment uses the same principle as the fiber of the cable. It is due to refraction.
And also, total internal reflection. So I'm going to read you the definition of each. Refraction is the bending of a wave when it enters a medium where its speed is different. The light bends due to very fine density of the mediums.
Yes,
That's how.
and total internal reflection is a phenomenon that occurs when a propagating wave strikes a medium boundary at an angle larger than a particular critical angle with respect to the normal to the boundary. So it's kind of like a little mirrors through a tunnel. So the lights will go flow through the mirrors and follow the tunnel around.
So why do we say that the coin earlier, when the coin disappeared under the water, is the water?
Yeah.
is it total internal reflection? Because, wait, yeah, because it is through very fine mediums that you can't see what's on the bottom. Because air and water, the light has to go through the water to go to the coin, so the coin can't be seen.
Yes, but at the top, we can still see that
Do you want
the
to see
coin
the
is
coins?
still there.
If
Okay?
you want to see the coins, for the people who haven't seen it yet, you can see from the top. The coins are still there. Do you want to see? You can come
Do
closer
you
if you
want to
want
see
to.
if you want? No, you don't want to. Okay,
You
come on,
get
come on.
it. You get it.
At the top. The coin are still there, right?
Yes.
So that. Okay, for our last experiment,
It is also about total internal reflection.
yes. So we'll also use a laser for our experiment.
Firstly, you will need water. So I'm going to fill this beaker with water.
And we also need antiseptic.
So you can find antiseptic at any beauty supply store like Guardian or Watson's. You can find antiseptic.
Just be careful
tiny
to
drops.
read the label correct. Okay, so I pour a little bit of antiseptic. Okay, and
You can
then
see that it gets cloudy. And this is the solution that we are going to use to show you the total internal reflection. But to show it, we need to leave it overnight. So we already prepared one for you guys.
so I'm going to shine this laser into the solution. As you can see, it reflects.
Can you see it?
Can you
It's
see
a
it?
It's a bit
hazy.
yeah, because of the lighting. You can see that the laser forms an X in the solution. Can you see it? Yes.
Yes, you can.
Okay, so if you can't see it clearly, I've drawn it here for you. So,
See, the same. You can see that it is the same.
so the reason why it forms an X is because of total internal reflection. Total internal reflection happens when when it is done at a critical angle. The critical angle for water is 48.8 degrees. So when you point it, it will be reflected back. Usually, if you point it at an angle smaller than the critical angle, it will just go up.
For an example,
See, it will just go up. But if you form it at an angle that is larger than the critical angle, which is 48.8 degrees, you can see that it is reflected and forms an X. So that is all for us today.
thank you
But
for your.
Before that, I'm going to give you with two facts about our experiment.
Yes.
About light and sound, which are the speeds of them. So light is actually faster than sound. The speed of sound is 343 miles per second, while the speed of light is 300 million meters per second. So that's it for us today.
I'm Aiman.
And I'm Deena. Thank you for listening to us. Thank you.